You take it out and then there's higher ones. When you take it out, oh, okay, so it is meant to be like that.
Thanks.
What is the password for the
for Q. Yes.
must use the
This is not from me.
Oh, well, I mean, I went home. So. Figured may as well do it now.
What if I wasn't ready for it?
And hold on to it until tomorrow when you are ready for it. trying to get some tricky questions.
Just from Yonki.
Yeah.
Read the science.
Oh, whoops. Who's at the run today?
The less people, the more questions I can ask and feel okay with myself.
The less or the more? Oh. Wait, did you say the more people? Or the fewer people?
Let me just say it again.
Okay.
The less people that are here, the better I feel about asking questions.
Okay. Okay. That's what, like, expected, but...
There's less people, no one preventing from concentrating on science.
Less people means taking away time for their questions.
Oh, it's already time.
What is the topic for today? What are we
Topic?
learning?
Something.
So do you know the story behind the file in your bin, absorption_DOS? No?
Well, I shared it with too many people, so I don't keep track of any. So who we are and what are we doing? We are trying to present skills on WASP in about a week and today. The WASP is harder, less user friendly. Pictures sometimes are not as nice, but it is with all disadvantages, it gives broader range of opportunities for competitive publishing. And we are going to So there are 8 people, hopefully, and there are 8 subjects. I will show choices that, based on the election, they go, but the subjects are input files, orbitals, momentum, anions, cations, the spin and multiplicity, spectra, and different aspects of molecular dynamics. So today we will for sure do the spectrum. Next time we will for sure do molecular dynamics. Okay? And I will try the other subjects as well. Also, please don't hesitate to express your initiative and ask questions. So, even if by some reason your task schedule doesn't allow you to follow plan of homeworks, you may try to do them, because it is kind of test. If you are able to do everything, it means that you're fine. If some offered exercises seem challenging, it means that you better consult in person, so that it will not be harder at waiting times. So this is where we are in the course. And if you are familiar, oh, by the way, do not listen to me. Just log into cluster and practice whatever you like. I'll give instructions, but you're creative young scientists, a list of a globe, you can be ahead of whatever I remember here. So log into cluster and try to do spectral orbitals, look online how to do them. You can do it much quicker than I will explain. So try to match your skills in WASP to the level you have in Gaussian. So if you are familiar with this GMD software, and I know that at least 1 or 2 persons are, you can, by the way, cover it in your presentation, because the VMD is the best way to plot orbitals based on WASP calculations. Although there are tools to convert WASP orbitals into Gaussian cube files and then plot with your favorite Gauss-U, but this will be the quicker. VMD is one of the few pieces of software that read WASP output directly without any conversions. The VMD software is installed on all these boxes. So, and if you want to install it yourself, I'm kind of lazy to guide you how to. I may have recorded a YouTube video on this, but it is natural. You just look online how to install VMD, and it is free in a sense that you do not pay money, but it is not free in the sense that you need to disclose your identity. You need to send your email, and then they will send you email with installation key. But this is visualization. We will go over needed calculations and then visualize needed files with VMD. So spectra is primary goal, orbitals is secondary goal, and anions, cations is likely we will have time. And spin polarization is very needed to those who do magnetic materials or metal organic complexes, but I'm not 100% sure that we will have time to cover it today. And next time we will be primarily on molecular dynamics and also momentum dispersion, which is, you do not need momentum dispersion if you are chemical chemist and you work only with isolated molecules and never work with solids. So there were 6 attendees of class, and there were 2 spots, 2 subjects that no one allotted for. So I frivolously distributed those who were not allotted to missing subjects. So Austin will present on spin polarization and multiplicities, and Russell may want to approve the aspects of molecular dynamics. And if you have steam and wish to go over standard things, you may learn aspects that I'm not going to cover. So-called nudge elastic band, NEB, which is additional script. It is not included into standard VASP distribution, but you can download it. And it allows for transition state search based on VASP. But this is additional thing. You can do it only after you learn how to do molecular dynamics. I was waiting for this call and I will answer quickly and get back. Hello.
Sounded a bit Canadian.
I thought it sounded exciting.
Yeah, it was like an excited Canadian. Hello. Anyway, so this file called absorption_DOS_PC.sh pretty much does everything to create DOS absorption spectra and partial charges for every.
Isn't that basically everything?
Yeah, that's why I asked him. It looks like Levi compiled it.
Dang.
And I copy and pasted, made another one with underscore my name .sh, and so it didn't work for mine. Like it made the DOS.
My phone call will be recorded and the video. So, Russell, you don't object? Okay. Molecular dynamics will be easier because I do it every day and I will be happy to help. But naturalistic bandit is a challenge. So, if you like challenges. So, I want to believe that you know how to run VASP and you have completed the homework, or you didn't have problems with it. So give me a little sign if I need to remind anything from last meeting, or you kind of aware of what was going on. Okay, give me a sign if you remember what was last on last lab and.
Oh, yes, I remember.
You do remember, right? So you can convert XYZ files into VASP format, postcard, and you can run minimalistic VASP jobs.
I have questions about creating the K-points file and what to choose for the K-points.
Just take a sample from tilde/bin. Do not right now. Do not use K-points file which is specifically prepared for gamma pointer.
Okay.
Yes, you know where to take it from.
I know where you keep all of them, but
Okay, and if you there will be like words, then 3 numbers 0, 0, 0, and then 3 numbers like first 1, 1, 1, and then 0, 0, 0. This number is 1, 1, 1 can be replaced by 2, 2, 2.
Miller indices.
No, number of key points in each direction. Spacing of grid points. If you do not have spacing of grid points.
But I mean, how do you choose which one works best for your system? I guess.
The larger the better.
Always, no matter what.
If it is metal, the larger the better. If it is molecule, you do not need distribution of K points. And anything between metal and isolated molecule is your creativity.
So if I have isolated molecule with vacuum on all sides, and I just need 1, 1,
You
1.
do not need any distribution of K points. It is gamma point only, guaranteed.
Okay, that makes sense.
So you all know how to make density of states images, right? Russell? No? Can you do images of density of states based on VASP output? Okay. Then I'll better quickly cover it. Otherwise, it will be too much to cover later. So, if you are, it's boring to show presentation. I'll better do it actively. And maybe for recordings, I'll better focus camera on the screen. I'm not sure where is the receiver of this signal. I don't know where to point this. So if you may have some models to play with. If you don't care which model to take, you can borrow one that I'm playing with right now in the directory. But the practical steps do not depend on what you do with. And as soon as you get an idea, you better practice rather than listening to me. So, sometimes you just get it and you do not need any additional words. So upon you run VASP, there is a developed file which is named outcar, right? So, and if you scroll through this outcar file, it is same as log file in Gaussian. So if you scroll it closer to the end, you will see records that give you a list of orbitals. So right now it is on the screen. So it is very close to the end. You see a list with number of absolute number index of orbitals, energy of orbital in electron volts, and then occupations, 2 electrons and then 0 electrons. You may just copy this section and call it states, or you can do like parse this part out of file, like tail outcar tail minus n 300 outcar into states. So I do have this file, and I parsed only last 60 of it. So after I do have this states file, there is a what is density of states? So it number of energies, number of orbitals per energy interval, right? And each orbital is addressed by Gaussian profile. So there should be a script code which will look for the list of orbitals and create the continuous distribution. When this code was written many years ago, and it is not mouse operated. It asks silly questions instead of reading from files. And before running it, one may want to get some basic information about
Thanks.
the calculation.
That you never use that.
For example, if you get like value of Fermi energy, it is needed to shift your
Not right.
center.
Uh-huh.
Today.
Okay.
So and also you may need the
Script does everything. So if you actually test it.
number of electrons and number of
DOS.
ions, which is needed for normalization.
I think PC did.
Oh. Whoops.
So number of states,
Yeah.
it was just
Oh,
WC
yeah.
of the
No,
file.
yeah.
69. Minimal energy, maximal
Yeah,
energy.
mine actually.
It is the window, same as in
So,
when you
I'll
were
copy it
processing
over and
Gauss.
check.
Created one.
-3 to 5 Fermi energy.
Oh, it worked.
Is that convenient?
Yeah. Awesome. Thanks. I got mine to work.
And the
But now you
width is same meaning as in our Gaussian.
You'd have to go.
How broadening of each
Yeah.
line.
That's fine. I mean,
Number of ions. 40.
it's cool.
Um,
Yeah.
electrons 272. And upon completion, there should be DOS Fermi file, which has continuous distribution. So if you love Origin or Excel, you can just open this, download this file, dos.fermi, and plot it with your favorite program. If you do not want to, if you do not like them, there are some scripts that visualize, just make graphics. So GNU-plot is actual program, and the stuff here is a very brief script. So this is a couple of lines, but sometimes you're getting tired of typing it again and again. So upon running the script, there is a file dos.ps, which is an ancient obsolete graphical format, but you can do PS to PDF conversion. And then you get it in modern and shiny PDF format. And if you are doing mobile extern, then you'll get something like this. So here in this version, it is not shifted to the Fermi energy. It shows absolute values that are taken from states file, and the occupied are marked by fields. So you can easily identify where is your occupied or unoccupied system. Today I do plan to speak a little bit of anions and cations. I have already forgotten who will present it. No one of who's.
Might be me.
Maybe you. So anions and cations, it is when you remove or add electrons, right? And if you take the same system and create a cation, it will show basically the same recompute, the same density of states, but there will be no filling here for removed electron. And if you create anion, there will be a little red hue because there is an additional electron. We will go to this exercise, but there is something even of higher priority. Russell? Will it be sufficient for you to reproduce things if needed? So the system that I am playing with is the one that was question number H in extra credit in the homework. I know that Daniel was playing with it, right?
Which one?
The cubic perovskite.
Yeah.
So the image should be something like this in your of the density of states, more or less. If you were, no?
Yeah, I think so, but I probably took a little bit more. Yeah, I used the scale from like -10 to 4.
Okay.
So I think if I did zoom it in like yours, it would look like that.
Okay. There is no, if you are not doing X-ray or far UV, you don't care what happens away from band gap area. In chemical reactions or in optical probes, all the vicinity of the gap states are perturbed. Whatever core states, like 20 electron volts below, do not affect if you do not do X-ray. And very close to gap, just few electron volts away, like 3, 4, 5, it will be ionization when your system will be not your system anymore. It will be ionized. Example of photo effect. And feel free to borrow geometries from my directory if you need.
Do we yet know how to change multiplicity?
Oh yes, I do. I want to cover it today,
Great.
but let's do much higher priority, the piece of paper that I have distributed. So main thing to probe anything is spectroscopy. I don't know, maybe I'm too ambitious, but characterization of materials is typical interaction of light with electromagnetic wave of different frequencies. In your characterization experiments, you may change the frequency from radio frequency for NMR to X-ray frequencies, but it's basically the same. And UV is one frequency is of the order of the gap for typical molecules in semiconductors. So we may want to see response of molecules for optical transitions from occupied to unoccupied, right? And we do need the transition dipole matrix cell, right? So if you implement this equation, it will characterize ability of your system or pairs of these two orbitals I and J to participate in the optical activity. And as soon as you do have, as you are able to implement this equation, you can find spectra. So if we skip details, the absolute value squared of transition dipole matrix element is oscillator strength, which is literally the rate how quickly light of given intensity promotes orbitals from orbital I to orbital J. So Fij is proportional. There are some fundamental constants and frequency, but we will get tired if you put all details. And then if you take all occupied orbitals, I less than or equal than 4, all unoccupied, J bigger or equal than 4, look for oscillator strengths between them and multiply it by energy difference. You'll get an absorption spectrum for something that is very, very close to absorption spectrum. It can be a little off by absolute values, but if you use right computational chemistry method that predicts you right energies of orbitals, right shapes of orbitals, you will be very close. There is a next level of theory when this is approximation of independent orbitals. This is not perfect, but it is very quick to start and get into the real world. Later on, in all excitation, any true excitation is superposition of multiple elementary electron hole pairs. But right now we don't care. We just need to do something that is related to the spectrum. So we are going to implement each of these equations and get spectra of any model that we deal with. For like approximately half of the class, it will be main skill from the point course. For another half, it will be molecular dynamics. Yes.
So it's impossible to create like NTOs because you can't have more multiple, right?
Later. Right now, we are not preparing correlated excitations.
Yeah. So using this method, NTOs don't exist.
We do miss attraction of electrons and holes. We do miss bound excitations. It is not excitons. It is independent electron hole pairs. So I don't know how patient you are. Therefore, first I will show the result, and then we'll go through details. So when we were looking on the density of states, suppose that we do not have patience to look into the numbers and we look only at the figures. We see that the gap here is about like 1.5 electron volts, right? So the absorption, the minimal energy at which the system is able to absorb will be 1.5. So it is here, right? The next transition will be maybe something about 2 electron volts, either from HOMO to HOMO plus 1 or from HOMO minus 1 to HOMO. So they both will be about 2 electron volts, maybe a little higher. So, okay, so it does correlate with density of states. If we do not care about oscillator strength and height of the peaks, we can drop computation of this part and just do epsilon here. And do just transition energies, energy difference between source and target orbitals. But if we are interested to see if the transition is dark or bright, we also need this transition type. Okay? Very, very soon, when we will be going through the procedure how to do this spectra, oscillator strengths, we will run into the following challenge. At least few of us, I'm looking on Russell, are paving, planning career in experimental research. And UV spectra on experiment rather than theory are typically plotted as function of wavelengths, nanometer, rather than energy. So looking on the spectra where the x-axis shows transition energy could be unnatural thing, or natural but not comfortable. Of course, you may convert, or you may demand of audience of your spectra to convert electron volts to nanometers by 1242 nanometers per 1 electron volt, and flipping the direction of x-axis, right? So this will be 1200, this will be like 600, so the first peak will be about 700 nanometers, right? And then you go to close to this, whatever, 500, 400. This is too simple operation that we can implement immediately into the way how we convert this stuff. So we can just rearrange it into nanometers. And then here is the spectrum. So the lowest transition and then higher energy transitions. So for any model for which you do have successful calculation of WASP, job complete, you do have outcar and wavecar, you are able to do the absorption spectrum. Of course, then if you try to publish and defend this result, some knowledgeable people will ask, where are your NTOs, or where is your electron hole correlation? But for some systems, this will be sufficient. And it's better to have something than nothing. So this is only the first step in the ladder of precision. There are ways to get more reliable and more precise spectrum. But for anything good, you have to pay. This is much quicker. So we will invest whatever time we need, I don't know, 5 minutes or an hour to the level so that you will be able to do such figures. And then I will make a circle and see that you all got them. So the first thing is to copy to rename your states file into energy pop. There is no science in it, but it's easier for me to, and maybe probably for you to just rename one file rather than recompile the code or suite of codes. So you need to have this energy pop, which just list of orbitals. And then you need to make sure that you do have non-zero wavecar file. So wavecar is analog of check file in Gaussian, and it is where the script will take the orbitals. And then you do need to prepare the input overlap file, which contains service information. So first orbital that you have mentioned in your energy pop, and last orbital that you have mentioned in your energy pop, and then just number one service number. Why these numbers are needed? So if you look from maximalistic point of view, you may decide like, why don't I look for transitions from each to each orbital? You're correct. It is right. But if you are using if you have limited numerical resources and especially limited human patience, then you may realize that it is just second power. amount of effort, numerical efforts, will be number of involved orbitals squared. But very often, you do not need to go more to the transition energies more than like 5 electron volts. And if you take all orbitals that are available, it will be just waste of your time and effort. So you may focus only on the narrow limit near the homoloma gap. Even with this limitation, it will be, this methodology will beat TDDFT in a sense that suppose that you have 100 occupied and 100 unoccupied, or here maybe 30 and 30, which means 30 times 30 will be how much?
900.
900. So it is 900 excited states. Can you run TDDFT with 900 excited states?
Quite a bit.
Yes. So since here one doesn't recompute adjustments of orbitals, your NTOs and electron hole attraction bound orbitals, this is very cheap method, and you can easily do many excitations. So after you create this service file, it is here. I'm going through this. You are doing finally yes, diagram version 3. Yes, WV3. So there were several young researchers who were trying to run it, and you see that the source codes are available. So as long as you in class, you have permission of authors to use source code. If you want to use it after, let's discuss it, but there will be no problems as well. But if you don't care about recompiling, just run the executable, and you will see some garbage which is not needed if you do applications, but is needed if you want to redo the code and for debugging purposes. So it just gives you reports how the information has been read from the wavecar, how the pairs of these orbitals were conjugated, and finally it gives the report that the calculation is completed. If you are trying to recompile and rerun, sometimes it stops somewhere in between and doesn't generate healthy output. It is only for this need. So I invite you to do the steps right now, and I'll go around and see that you are with me. It's not very challenging. If you go too far, then it will be more difficult to follow and catch. You see this, right? Okay. print out the this.
Where?
Modifying that script that doesn't that
Oh.
created your DOS.
Okay.
'Cause it's so close to being able to create the PDF of the spectrum as well.
Yeah. Or you just like know what to change in there.
Huh?
Work in your errors.
Okay.
Oh, true.
It says line something something syntax.
Yeah.
One of them are legal scripts.
You show the whole class that if someone watches in recording doesn't feel bored and know how far to scroll, because if there is a empty screen and there is no motion, it will be extremely boring.
Hey, what is the syntax for is it new plot?
Yeah.
Plot some. This is the name of the file that you're plotting.
Mm-hmm. Same.
So that should be here. Dress spec dat. Dress spec dat.
Mm-hmm.
Okay, so there's
There's.
that's not right.
Yeah.
Okay, never mind. See, found the problem. We'll attempt to fix.
2 decimal places.
Okay,
It's
so does
only
this-
one call out.
Does this look like the right syntax?
Yeah.
Okay.
Yeah, the syntax is entirely correct. Yeah, I got it to work.
Okay, and you too, great. What's
Yeah.
the latest trends?
Yeah, I can do that. Yeah, I have the oscillator string file. Yeah.
Okay, good. Yeah. So, what is the meaning of this oscillator strings? If you do like more, you see how many 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. Can you guess what is encoded there? What is the content of these columns? Well, I do not have time and energy to keep the intrigue. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. What is shown here? What does this symbol mean?
It's a vector.
So how many components typical Cartesian vectors have?
3.
Good. Let's work on it once again, or maybe simultaneously on these 2 records. Yes. Which symbols are placed here?
The index for your initial state and the state that you're trying to transition to.
Okay. So if you're looking on a specific single elementary optical transition, first, you need to specify source and destination orbitals. And second, there should be 3 Cartesian components, because D, dipole, has 3 components: dx, dy, dz. So, source orbital, destination orbital, dx, dy, dz. Logical?
Yeah.
For most of things that we do, we will not need it. But some of you are rotating plane of polarization. Some of you may do chiral catalysis. Some of you may love Vikings and Icelandic spar crystal. So some materials have very strong anisotropy of the transition dipole components depending on the orientation in space. And if you're going to investigate such materials or such properties, you may go back to this lower level information. For most of us, simple guys, is just background technical information. So this one is oscillator strength, is what we have here. Transition dipole absolute value squared times some constants. So since we have absolute value squared, it is scalar, right? Just one component. And on this example, for this system, probably this is HOMO, this is LUMO, and they have huge values oscillator strengths. Here, it is not normalized, therefore it is bigger than 1. But relative values are good to compare. So what are the other columns? So if you do need to put a spectrum, we need transition energy, delta EIJ, which is epsilon j minus epsilon I, right? Offset, and energy offset of the source and destination orbitals. To match resonance condition with incident light. So for out of available energies here, this HOMO LUMO, probably this was for single titanium hydroxide. So 3.4 HOMO LUMO gap. So what are these 2 columns?
Which 2?
This number 5 and 6.
Just saying you're going from an occupied one to an unoccupied.
What is it?
Just saying you're going from an occupied one to.
Yes. So number of electrons on source orbital and number of electrons on the destination one. Right? Why do they have so many zeros, so many digits? Why they're not just integer 0 and 2 or 0 and 1?
You can have partial occupancy.
Why, in which cases you have partial occupancy? This is more typical for physics situations rather than chemistry. In chemistry, it could be like some radicals, but also it's not a favored object in chemistry. But in physics, very typical. So, partial occupancy. When Fermi-Dirac distribution is needed. Of course, you can answer always.
Non-zero temperature.
Non-zero temperature. So if the system is exists at highly elevated temperature, so then there is a not optical but thermal promotion of occupation from HOMO to LUMO and further. so that will be fractional occupation. And high temperature in comparison to what?
Okay.
Yes. So if you, through Boltzmann constant, you convert Homo-Lumo gap to temperature, and then you compare it with temperature that you assign to your system. If they are comparable, then you get partial occupancies. For about 1 electron volt gap, such temperature will be like 5,000 Kelvin. So in the real world, if you're not looking for the exhaust nozzle of rocket, we are safe for regular materials. But there are materials that have this ratio comparable at room temperatures. And again, it is a question to those who are happy with their physics background. Band gap converted into temperature will be comparable to room to 300 Kelvin. Should be big or small gap?
Room temperature is 0.025.
Yes. So if you small gap,
Yeah.
Okay.
which materials have small gap or no gap?
Metals. And
Yes, yes. So fractional occupancies are needed for hot metals.
Okay.
Okay. You know everything. You know each column in this file. Yes.
Specifically, like in bulk, right? You mean?
Even if you take if you talk to Jabet, who does metal clusters of 5 atoms, they're not metals. It's more close to metal organic complexes. They will have big gaps. But if you have a decent size of nanostructure of metal, like more than 2 nanometers, gap will be negligible. What is our goal? What are we going to do next?
Plotting.
Who wrote this? Yes, correct. So we need to, right now we do have the list of transition energies, and we have heights of the appropriate peak. But again, we need, hi Alice, how are you? You came at the right time.
Sweet.
So we need to convert this list of discrete data points into continuous distribution. So for each transition energy and oscillator strength, we need to create a smooth profile. Why do we need it? Again, if you are chemical chemist, synthetic chemist, that work with small molecules, or if you are atomic physicist, you have very few narrow lines in spectrum and you do not care. But if you either work with more than 100 atoms molecule, or you work with like semiconductors, distributed systems, the amount of transitions, even per small energy interval, will be very large, and you just get tired of looking at many peaks. You need to have continuous distribution. Make sense? Same as for density of states, we need to convert discrete list into continuous distribution. I'll tell how to do this, and then I'll go to Alice and repeat everything we did for last hour. More or less it is reflected here. So WC in this circumstances means word count. So it means how many transitions you have in your list of oscillator strengths. Then you write the script. With very creative name. Spectrum improved version 3. So number of transitions for the model I'm working with was 1184. So now let me just show it. If you look at the spectrum, you need to specify at which interval you want to look at the spectrum. For example, if you look in the infrared low gap, you do not care about UV. Or if you know that there is a very large gap, you don't care about infrared and visible. So you may tune the range in which you are looking on the spectrum. If you don't care, you can be liberal and take from, do not put literally 0, put a little bit above 0, because when you convert into nanometers, it will be dividing by energy difference, and if you have 0, the code may panic. So from 0.5 to 0.01 to, let's say, 5. Width of line maybe comparable to thermal. Homo in VASP. You can look back into your energy pop file, but I already know for this system. And typically the top record in the oscillator strength shows Homo Lumo or very nearby, so 136 will be Homo. This is needed for normalization purposes. And then if the script is successful and it tells spectrum file is reader. After this, you inspect your files and you see that you have file named spectrum. And again, if you love Excel or Origin, you can download this file and plot it there. It will have column corresponding to transition energy, column corresponding to density of absorption or like value of spectrum. If you talk to rigorous people, they may talk to you in the language of absorption cross-section. But we do have scripts that work under GNU plot. So you type GNU plot, and hit enter. After you complete it, you do have sp.ps, which is basically this file but in PostScript format, which you may not like. So if you want a modern and shiny PDF, sp.pdf, spe.ps. And then you have this SP PDF that you can download and watch. If you need nanometers, SP nanometers. And there are several versions, so if you can specify the range. SP nanometers, PS to PDF, SP then if you're using mobile extern, you'll be able to download it
I don't
through your
couldn't tell you.
browsing menu. Oh, I have already got it there. Okay, so please try to get figures like this on your terminals.
Not satisfied with the DOS yet, though.
So first one was registrants. Oh, I'll get back.
I'm not satisfied because. Maybe I didn't want to modify this script.
As long as you create a new file.
I didn't.
Oh. Wait, what are you talking? I thought you did.
Mm-mm.
Oh. I don't think he'll
Okay. I will need.
be happy.
I mean, it's essentially the same thing.
Okay.
There was just a typo, so he must not be really.
Yeah.
Could be a great discovery. Then you will right afterwards.
Yeah, K points kind of throw me off a little bit.
Same.
Yeah. Don't have a good
But you know,
understanding. It's one of those things where I think about it, and then I think I understand it decently,
Mm-hmm.
and then somebody talks to me about it, and I have nothing. Zero.
Here's one thing I understand.
What's that?
That my Lincoln chains are too smart.
You still have that?
Yeah.
You gonna ever delete that?
No. You gotta admit, that was too good.
No, it was pretty funny. I will not complete. Where's mine? Okay. Alright, let's see if this last correction fixed it. Think it did? I don't know which column was which, but.
Mm.
Mmm. What are the new columns up there? Okay, what is the actual?
I don't know.
Which one of these looks like this? This one.
Yeah, definitely that one.
Okay. Then
The other one, there's a big gap in between like 2 and 3. Oh wait, never mind. I think they're both actually fairly, because they're both on different parts.
Oh, one is the occupied, one is the unoccupied, isn't it?
Yeah.
Shit. Why would you write it like that, Levi? That's dumb. Make a third column with the whole
Right.
thing. That's upsetting. Good catch. Yeah, I don't know if I would have caught that. Well, time to go change that. I think that'd be easy to change that.
Yeah.
What file? What script is that?
Hey.
Oh, in his script. I'm gonna have to go change his script. No, it's not. Oh, yeah, you're right. I did make another script that was also probably written by Levi.
Okay.
But that script calls other Python scripts. That shell script calls other Python scripts.
Yeah.
And it's the Python scripts that I ended up having to go change.
Oh. Okay.
To clarify, I see the confusion now.
Yeah.
Oh, no. Is it test plot spec? No, that's the new. Okay, I'm confused now. Must be in spec. Dress spec deck, yes.
Seamless.
No.
Yes.
Rodney Johnson.
Yes.
States, dress, dots, dot, dot.
Hmm.
Aha, here it is. Revenue occupied virtual, but not vault. Okay, where's number?
My thesis is 117 pages.
But over here.
No, it was around 120.
Make sure that it. I have forgotten to make it less boring on the recording.
Levi always makes things unnecessarily complicated.
Oh yeah.
Yeah.
Oh, that's the window?
Yes.
I'm going that.
Minimum and maximum.
That sucks.
Should be out of This is for different
And he doesn't comment anything ever.
Oh. Sounds kind of like me. I guess I comment a little. Like I was reviewing my thesis and I realized how little I actually do comment.
But I mean like scripts.
Oh,
Scripts and code.
yeah.
So you just yeah. Yes. Super.
One of these is from Braden. This one's the one I generated using the methods up there.
Okay.
Yeah.
Brilliant. I find you spectral.
Yep.
Good.
I'm trying to develop an easier way to do it all over. Piggybacking off of Levi.
Huh?
Levi had written some stuff that does all of it at one time.
Yes, but it didn't help anyone except you.
It'll help me. Although I'm making it better.
I'm not against it. It's a useful thing, but focusing on mechanical part may disfocus you from scientific part. Just in case. So, how should we entertain each other in the remaining time? What is missing in the program? If you go to scaling. Well, anions, cations, excitations is easy.
Good.
UV spectra were also easy, but they're extremely important. You can have your piece of bread and butter based on this procedure. You probably should look on the orbitals before we go to anions, cations, K points, and other things, so that our skills in WASP are not worse than our skills in Gaussian. So the orbitals are stored in the wavecar file, and when we were practicing Gaussian, we were running CubeGen script, right? You may expect similar procedure in WASP to run some script that will extract cube files that can be plotted out of wavecar. Let me tease you and ask what is your opinion how the analog of CubeGen should be named for WASP output? trying to guess maybe not fun, but learning the answer will be fun.
Is it like cube car?
No, but I like the direction of your thoughts. Any other guesses?
Bar chart. Bar chart.
Well, it is instead of ch instead of cube file, they will be named bar chart. But which code allows to generate analog of cube files? What is the analog of cube gen? How would you call it if you would be Austria-born German root author of WASP? Very logical thinking. Mathematical logical. No, it is not related to any language. WASP. You just run WASP once again with different in-car. And then it reads its own output wavecar and generate the files analog to cubes that can be plotted. So we just need the right template of the in-car file that will allow to convert. Never do more wavecar. Well, no one will kill you for this, but what will happen? First, your screen will be garbaged by unreadable symbols, and second, if you try to type something, it will generate also unreadable symbols. So it will screw up the settings of your terminal program, and you will type like LS or CD, and it will ask question mark, number, minus. So we need to convert wavecar into something reasonable. So I'm going to the binary and copying the template in-car-pc for par charge into the in-car into local directory. If I'm very meticulous, I may reopen new directory for each job for orbitals as well, but maybe not today. So there are two things that we need to modify in this in-car. So one thing is number of bands, which is number of orbitals. And what is NBA?
Natural bond analysis.
Well, I'm with you that it is not National Basketball Association. But here it is number of bands, which is like number of orbitals. So 168. I'm parsing the value of NBA, which is n bands variable 168. 60. Okay, this is fine. Yes. What? Oh, okay. Oh, yeah. Thank you so much. Yes, yes. I appreciate it. Good. Yes, it will help to those who watch recordings. So, number of bands, and another thing, the energy interval. So it is the same thing as we placed in the when we were plotting density of states and when we were selecting the interval of orbitals which participate in optical activity. So what this input file will get out of WASP, it will generate many orbitals with energy starting from here, ending there. And if you do not want to garbage your directory, you may want to be humble and request narrower interval, unless you have research necessity to look through 100 orbitals that you will get tired to plot, by the way. So where do I get this the numbers? So I look into the list of orbitals and I will look on the vicinity of the HOMO-LUMO. So it's near 0. So I may request maybe from -1 to 2 will be plenty of. But if you're doing different systems, you may look for range that will capture several orbitals here. There is a way to request individual orbitals, but it is less productive. If by some reason you need 200, you will be tired to type one after another range of orbitals. So I'm going to request from -1 to +2. -1 +2. And then there is I'm going to do something very simple and very silly, but it is an important step. CP contcar postcar. Do any of you have cats at home? Give me signals if you or your parents carry cats at home. No one? So what is a typical things that cats are doing when they do not know what to do? Huh?
They sleep.
And when they're not sleeping and not playing and not eating, they're cleaning the fur, looking at its own paw. Okay? So if you do not know what to, a plan of a cat, if you do not know what to do, lick your paw. Okay? So if you do not know what to do in computational chemistry research with WASP, do this operation. So contcar contains geometry that originates from your optimization or molecular dynamics or your previous run. Postcar is a geometry that is being fed in new calculation. So WASP code is pretending that it is stupid, or it just doesn't want to cooperate and guess your wishes. It has very straight logic. Like the input is whatever is stored in the file postcar. So even if you spend half a year on finding super ideal optimal geometry, but it is stored in your contcar, your next run will not use it, and even override your nice contcar file. Therefore, you better run everything, each new calculation in new geometry. Because otherwise it will be overridden if you have created something valuable. So the file names are not unique; they are standardized names. And if you want unique identifier, you better create new directory. Like when you doing Gaussian, you identify your job, your task, your science in the name of file, right? Like mysupermolecule.com or transition state search molecule.com. Here it will be always postcard, no matter what is your congenial thoughts are. And what? Yes.
Is there a way to get intermediate coordinates through an optimization?
Yes, there is a way to do it, but we are not doing it right now. But it is a standard task. Next Wednesday you should come through, and even if you miss it, I have intention to share this skill because it is needed when you compute non-adiabatic couplings. You need intermediate coordinates along the trajectory of either molecular dynamics or optimization. Okay, concar, postcar, and after that, by the way, I also want to show something what I did. So before bringing here to my directory the template postcard, I saved the original incar as incar old. I don't care, I do not need it, just as a matter of many losses in the past, it's better to make a copy. What if it was very successful input file that helped you to find something? As soon as you make new job, you use new template, you rename whatever is incar, and the old one is lost. So if you have fear that you got something valuable, you better save it. Same for all other files. Like if you need your outcome, as soon as we run new job in the same directory, old outcome will be lost. It will be overridden. So if by some reason you need it, you can call it car or if you need it. Maybe you don't. But those text files are not super huge, and in modern like laptops and clusters, it will not take much of space. Wavecar files, they take space. You do not want to replicate them 1,000 times. But geometries and energies, it's very humble. Okay, one VASP. And if I'm ambitious, I am requesting 8 processors. Okay, job is running, and you see the directory is populated by varchar files, and it is already done. Now it tells last goodbye, making this out and error file, and it will soon disappear from running status, and it will disappear from the list. So. So if the job was executed successfully, one is getting files that are analogs of cube files in Gaussian, and they are named per charge, and they are labeled by number of orbital. all K stands for it adds together contributions from all values of K points. But if you're working in gamma point, you don't care. If you working with momentum distribution, you may plot orbital for different value of K vector, and they may change the shapes. Okay, so let me go around and see that you are able to generate these files. And then I will return to the station and show how to plot these orbitals. Yes.
So I know we just talked about this. But, so this is just the energy pop file. So what does this tell me?
How many electrons are
Yeah, the gap is of the order of kT. Therefore, it's thermal excitation from home to home.
So here it looks like the
What is it?
black is occupied with red is unoccupied.
I don't know. It's not. Oh, you're doing in origin. I would prefer to plot one line for everything occupied and unoccupied, and maybe another line for occupied. Yes, they overlap, and such systems will have high mobility, conductivity, as we know about metals. But here it could be artifact of wrong vacuum spacing between periodic images. If, for example, it is not metal, but like titanium dioxide, which system is this?
It's the perovskite, but instead of lead, I have manganese.
All of them manganese? Or just one manganese?
I put all of the lead as manganese.
It is completely different story, and then you need to do spin multiplicity, because manganese is highly magnetic and it will be in the ferromagnetic state. So, actions. Or if you are impatient, just add the word. The one to tell as a joke a little about that. Apple products. They add the word I to everything. Right? So add word I spin into the ink.
I spin equals something, or just
Yes, equals to.
2? Oh,
Equals to Did you got the?
Yeah.
Did you get the per church files?
Mhm.
Per church files. Yes.
I mean, does this make sense to you?
No. Well, I mean, like what the file is.
No. Basically, why I'm getting partial stuff in unoccupied states when we're at 0 Kelvin.
Right. I don't know. I actually got that when I was doing one of my jobs for the homework. And yeah, I didn't understand it then either.
Just
My spacing is solid, but I haven't checked it.
Okay.
Not the issue.
Yeah, it was this one right here.
Which system is that?
It's the one where you have 2 titaniums.
So just 2 units?
Yeah.
So you also have partial charge on unoccupied state?
I guess, yeah.
You guess or you know?
I'm pretty sure.
Because I don't know if there's a correlation between that. I mean, there probably is.
Yeah, I don't know. Do you still like the freaking plot? Whatever.
Okay, where's my incomer? What did you say? I spin?
I spin, yeah.
Goddamn.
Yeah, I just lost connection too.
So you see.
Rerunning the simulation.
Wait, what? Apparently you can plot molecular orbitals in Mathematica. What can't Mathematica do? I was looking up how to plot them in BMD. I saw that, I was just like, wait a sec.
So you already know how to plot them in VMD?
I tried and I failed.
Try to.
Okay.
Do we have it right?
Probably.
In your postcard, you need our chart.
Right.
Our chart. Those kind
Do you need all of the par charge?
Just whichever one you want. Because
Okay.
each one is an orbital, so you don't need one.
Or okay, so I'm gonna load both of them.
Sounds like a good choice.
Okay, so obviously that one worked.
How we do?
Par charge. Okay, so here's par charge.
Huh? Oh, it is. You need bigger font there. You should show it. Oh, like, I was asking it several times, everyone, and then I stopped asking.
Okay,
I do not know how, but I'm sure it is possible.
so and I can't see any orbitals.
Okay.
Yeah. So grab it.
So, click on Arch. And then
If you go to tools,
Huh?
if you go to settings,
Oh.
Settings. X.
And then configuration.
Okay,
And then
great.
terminal.
Points.
And then
Mm.
And then if you just want to walk through it again, I feel like it would be helpful for people who are watching
Ah.
it too, since
Huh?
if you want to like go through it again on your screen.
I will go through on your screen right now.
Okay.
I'm going
That's
to.
better.
Maybe it's a
Didn't
little
change the
too small.
But yeah.
The idea is that-
Okay. Yeah, I changed it in the wrong direction.
Yeah, and without the postcard file, you won't be able to see atoms because apparently it doesn't store
Right.
atoms.
Okay. You can even make them transparent.
Maybe it will be activated when I open
Okay.
another
Except here you only have partial charge distribution for
connection.
When you were plotting over the Gaussian, they were essentially the wave function.
Gotcha.
And so there was a red and blue.
Yeah,
Here
here
there's
it's just blue.
Just one. It's just charged inside.
Gotcha. That's pretty cool.
And so for Gaussian, then you need to add another representation. And then change the alpha value to the negative version.
Okay.
So that's how you get the wave function version.
That's so odd.
Yes. Okay. That's perfect.
Yeah.
Thank you. Okay, when I do something next, you'll see, but now I'll better approach so that you need to.
Can't go to the
Mm.
Yes.
Yeah. That. Because I can.
The pretty far apart.
Yeah.
What is that, 7? What did you choose? Remember?
No. I think it was like 11.
So here is number.
Javed says 10 is too much.
Oh yeah.
Anything above 7 is publishable, but 10 is
Why?
because then you have too much vacuum, doesn't it?
Oh.
You're
Oh,
just
so you
wasting
mean-
computational resources.
So you mean like between?
Yeah, if you just want to calculate
no.
a compound in vacuum
Mhm.
without using periodic ranges,
Oh, okay.
so it doesn't
Mine.
interact with itself
Mine was periodic.
in one dimension
Yeah.
between sheets.
Oh.
'Cause I assume your sheets shouldn't be interacting like across the way you just said. that.
Right.
Yeah.
Hmm. Yeah, I don't remember what I chose. It definitely wasn't 11 then. I meant 11 for the like the.
Oh, the length
Yeah.
of your thing. Oh, no. Different,
I thought that's what you
different.
meant.
No, I meant length of vacuum.
Okay.
Length of vacuum.
Yeah, that was probably 7.
Oh, shit. Just didn't.
I know it. It's cool. If something is wrong. Oh. If you see that something doesn't work, just change. If it works, you Just updates. It's already. But you
Yeah, I haven't done that. Yeah, I know. So I just.
Mm.
Hey. Oh, okay. I will let him enter. You see, not personal computer.
I mean,
Partial check. Partial check.
I don't know. I like my nanoparticles functions more. How do you do a nanoparticle? I should.
It's not too big.
Yeah.
How many silver and gold nanoparticles or atoms do you have per gram?
We don't account for that at all.
Yeah, but I mean, how large is you know? We can just figure it out very quickly.
True.
Well,
Yeah, it's like 60 nanometers in diameter.
60 nanometers?
Yeah.
it is
That's
related.
pretty. Well, you can just make a small
Not
one.
60, crap, just 6.
Oh, 6. Okay, that's okay. That's much better. So that's not even a lot of atoms.
Right.
So it doesn't even matter in diameter.
Yeah.
So it's 3 in radius.
Mm-hmm.
So what's
One-
silver bond distance is probably like 1.6.
I don't know.
2.
So although I did put large font here, we do not need it anymore. It will be done very soon. So right now we do have the files with orbitals, which are hopefully healthy, and we need to plot them. Orbitals exist in order to be plotted. So the format of the charge file is very similar to cube. So it splits space on simulation cell on discrete points and tell how many percent of electron is there. It goes over rows, columns, and then sheets covering three-dimensional space. The VMD program and basically any other programs that draw orbitals, they do two operations separately. One which Gauss view and Gaussian do together, but here they're separate. First, create image of the background molecule, and second, cover it with image of the orbital. I think it was a stage where Christian was stuck in one of the homeworks. So these two things, background molecule and charge density orbital, will not appear instantaneously. You need to make effort to plot both of them. So I am going to recall to myself what was the HOMO. Okay, it was 136. And then I'm going to download the per charge 136 if I have it. And I also need a file with the geometry, which will be typically Kontcar. Okay, they're here. Now I do need the VMD VMD code, VMD environment. And there, so I don't want to be too quick. So please please do 3 things before we go further. Download 2 files to desktop or anywhere on your computer. Kontcar and one of your favorite orbitals. Better the orbital corresponding to HOMO. So I do have mine in the desktop. So I downloaded the ParCharge orbital and Kontcar to local computer. If you are in the external, in command line, you can, or Linux, you can do it by SCP. If you are in mobile external, you can just click on to download on the left side panel. Upon you do have this files on the computer, just go through the list of installed packages and find the VMD that starts with letter V, just in case. Later on, you may find it useful to install it on your personal computer. And I saw that Russell wasn't wasting time and made sure that he has VMD already. And I know that Vijay and Braden had VMD on their computers from Kington. Files here. You have files downloaded? Okay. You can download the files. Okay, let's do it together. I'll do it. It doesn't have. You don't need to take the jokes. It's a joke or something else.
Lose connection one more time. God damn. Then we can't do anything. I can't leave this like SID for 1 minute.
Right.
It literally must be 1 minute timeout for this.
And now you need to
is such a bad thing.
What are you doing?
Creating a nanoparticle. That's not at all what it should be, though. This is why I do coarse graining.
Well, how does your silver particles bond?
What do you mean?
No,
Structure is
T7.
BCC, FCC,
FCC.
Okay.
It's real.
Wait, am I simulating one nanoparticle or?
Mm-hmm.
Yeah.
That's what I thought you were.
Oh, yeah. That's what I was thinking too. That's what I was trying to make.
So we could go invest and make a
True.
an FCC lattice or whatever you said.
Yeah, that would be easier. I was using Gauss view. And
Yeah, it's probably more difficult to
Right.
get a nice cube structure.
yeah. I wasn't thinking.
That's what I'm here for. That'd be cool. You could do that as your project.
Yeah. That's actually something I'm thinking about. Like, I want to do something with nanoparticles because this is the last year I'm probably going to do something with them.
Do two interacting nanoparticles.
Yeah. I like that idea.
Alice already knows how to do it and can instruct everyone. So, in the VMD, there is a So, in the VMD, you need to go to File, New Molecule, and then browse through your files. So first you select concar, which gives you geometry, and you need to specify the file type, which will be, you just go down, 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 until you see wasp or scar, which means geometry. You click load, and you may see nothing, but do not panic. If you do, I'm doing perovskite, some of you are doing titanium dioxide. Click representations, and it tells lines. You can try CPK or dynamic bonds, or both of them. CPK. And just increase the bond tolerance. Okay, so first you do have your atomic model, but the orbitals should be put on the top of it. You need it as two operations. I'll complete this and then stop by. So after this, you do need to file new molecule. The word molecule is not ideal. They meant new object. And under new object, you select your part charge, which will be orbitals, and you tell it is wasp part charge. Right now, we didn't start spin multiplicity, although Braden is very interested in this. Therefore, we do total density, spin up plus spin down. Later, one can make them separately. And you take load. So, the orbital, the density did not appear, but you shouldn't panic. there are little additional things how to make it visible. So you click on representations, and you see that it does want to show orbitals in form of points. This is a pathetic idea. I would prefer it as solid surface, and it's still nothing. But now you know the concept of isovalues. Now it has two large isovalues. What if we pull this bar and make it smaller? Okay? And if the bonds look too thick, you can make them thinner. And if they block your visual analysis, you can make them transparent. And if you do not like gray, you can make them of some funny color. So please play with it. There are additional things that you can do, like, well, many things. But let me walk around and see that everyone on the same stage. If you can, upon getting success, please copy paste the image and put it in the PowerPoint. I will make an effort to make it part of next homework, so that you are contributing to it. And if, now I'm talking to the camera, and if your name is, just a second, I will return this one. If your name is, if your name is Christian and you signed up to present orbitals, you definitely need to make screenshot of these orbitals and explain this procedure to your colleagues in the class. Okay, I'm starting a tour around. So for spectra, this is kind of guidelines for orbitals and just oh, are you waiting for the question?
Yeah.
Make sure that you're in. Start.
So like I'm in the thing that's trying to work on my homework right now, so this has got all of my best files. So I did run fast.
Oh, okay, so you didn't do.
I mean,
did step states yet, but you know.
No.
But you know what to do.
Am I doing that the same way that we did it before?
Similar.
Okay.
I'll skip it. We return to this states later.
Okay.
And then we can just
It's a cube and not a sphere, but it could still be interesting.
Well, so just delete something.
Yeah.
How many?
Uh,
Or a better question is, what's the length of that cube?
2 angstroms.
So you need to.
Yeah, I
add
need to
more.
blow this up a lot.
I would blow it up 2.
Yeah. Well, right, because I mean,
So that's
20
already
is-
quite a bit.
Yeah. I could just try it with it, I mean.
Well, of course you could.
Yeah. It's close enough to.
For big production runs, maybe you could blow it up a little bit.
Right. Yeah, I mean, this is just for fun right now,
Just
so.
for funsies. Didn't Reed say that yesterday? Funsies. Who said that? What was that in context?
Yeah, that was Reed. That was Reed. It was like
was
you
it
were
about?
asking. You were asking if you can have the particular solution just be.
Oh, okay. And I don't think you can because something happened.
Yeah, because you got 0 = 4.
Yeah, I was gonna go back and work that out.
Yeah.
Also, I said flush that out in my presentation today.
Oh yeah.
Yeah.
In Sam's dissertation defense, he accidentally called silver silicon too. It must be our little group. Must be a running trend. Eric corrected him though.
That's good. Right away.
Yeah. Yonki was there too. He's on Sam's committee.
Wasn't Alan also on the committee?
Yeah. Alan's also on Wyatt's committee, my committee, and Kent's committee.
Wasn't Savannah on his committee?
Yeah.
So Yonki and Alan did my talk and that talk.
Yeah. Alan's got literally everyone who's defending their theses or dissertations this semester, though.
That's incredible.
Yeah. I don't know how he does it. Oh, I can just. Dude, I can literally just output this as a Oscar. AG test. Crap, fraction. I think I'm gonna do Cartesian.
So what is the answer?
May I attract your attention? Anyone? I have forgotten. What does oscillator strength tell me? Why do I need it?
Gives you an idea.
Huh?
Oh,
No, no, no. Please.
Isn't it the strength of the transition? Basically, just how much the optical properties.
Okay. So ability of pair of orbitals to participate in optical activity. What was the version of Braden?
I was just gonna say that coupling of the two orbitals by a dipole moment.
Okay, squared. Because rate by third below the rule. But not the matrix element squared.
Okay.
So it's the rate of the transition induced by radiation.
Why is it? I'm just confused. Why is it called an oscillator?
Historic. The structures, cross capacities exist before we thought that molecules consist of some of them strong, some
Where did my
It's the same.
I know I saved it.
What did you
Yes.
do? Maybe we have the same file. Is it okay?
So you get so you can
Okay. It should be. Oh.
Then it's rather sexy that just so.
Wait, so that already just made graph out of the spectrum.
Yes.
Okay, so it's expecting the file
Oh,
to
you don't
be
have to.
inspected.
Yeah.
I mean, how
Yes.
does, okay.
Well,
Yes,
actually, you
yes,
should
yes,
let
yes,
us
yes.
let first of all,
So now we just give
just delete the
Oh,
so at Spectrum, we have cores.
oh, that's what goes.
Now we do have this
No, sure.
Okay, so that box was
Yeah, it's that right click on here.
okay, then good. Yep.
Specific devices.
Just do You went too small and then you have to figure out. Mine's okay. I don't know what happened.
It might not work in the terminal.
Oh, it's hard to.
Well, it'll be Control C.
Yes.
Yeah. But then that's, you know, in the terminal.
Wait, Landon, what are you trying to do in the terminal?
Copy and paste.
Putting it on my thing already.
Yeah, you can just do Command C and Command V.
Command C on mine tries to open like the search. Like that's like a computer.
Uh-oh. Wait, are you on Linux right now? Oh, okay, never mind. I don't know what I'm talking about then.
Do you have another one?
Yes, on the table.
Oh yeah, that was just like.
My shoes are clinking.
So move everything which is
Can't remember. There is something on here. I mean, we could just go to the file.
But try to open this.
Okay, I do have it. It's just like.
Okay. So we can.
Every time I do something, every time I try to go modify a file and enter someone, and I go back to my clicky thing,
It's
it
done.
kicks me off.
Yeah. I don't
So
know.
we're setting the home.
My terminal has never lost connection.
No.
Only my clicky.
See, for me, my terminal always loses connection, but when I tunnel through blank, it never loses connection.
Never.
Yeah, it literally doesn't. Like, I've left it for like 15 minutes at one
I might have
time.
to tunnel through something now.
Yeah.
That might be the way to go. I found 21,904 transition
Like
dipoles.
Jeez.
Oh, Okay.
Next transition will be.
Oh my god, I just solved my problem.
Just some
this is transition review. This is
I've already
It's
forgotten how
intensity,
to
yes.
set up the
Oscillator
mask.
gives you intensity.
Oh yeah, I need to change my in-car.
So
Okay.
please digest and have practice something. But I
Yeah.
What was it called? Oh yeah, ice. Oh, it did change. How do you run BASP?
Just run BASP.
There's the function to go through iterations.
That?
Yeah.
There's nothing.
Yeah. I mean, if you want more processors, but I don't exactly know how to do that.
Huh?
Are you kidding me?
I wish I was.
Freaking kicked me out already.
No.
That's unfortunate.
Right now, if you're not tired that you have a little bit of steam, you can do something a little more scientific. Let's plot both HOMO and LUMO. And by the way, I don't remember, was it possible to plot two orbitals on one image in Gauss view?
Yeah.
Same here, right? So that you be compact and do not replicate like 1,000 figures for 1,000 orbitals, but you can put a couple of them on one image. So I'm going to download one more orbital. So before I was downloading 136, HOMO. Now I'm going to download LUMO. Problem is, I probably selected some. And also, there is a. Some of you may like black background, but journals may not like it if you are thinking about submitting. Okay, so right now it is HOMO only, but there is a one can download another orbital. Make sure that it is you specify the format, was per charge density, spin up plus spin down. And it is not visible again, but right now nothing can scare you. You know that points for representing charge density is a bad choice. It is somewhere here. And if you want to, you can color code them. So instead of blue, you can make them like pink or red. Make them transparent if you want to look through. So, although some of you have selected and I hate this three-dimensional thing, the perspective. Oh, so much better. So if you do the same thing, if you draw simultaneously HOMO and LUMO of your semiconductor system in this perovskite, which I expect is a primary interest of Daniel, you observe that cesium doesn't have any density, any wave function, any orbital. The lead has only LUMO, unoccupied orbitals, localized on the red. And iodines, for the highest occupied, it is primarily on iodines with some contributions from them. So this is not as pure as it could be in traditional metal oxides. If you will do the same exercise for those of you who are doing titanium dioxide for practice, you may observe the same thing as we observed in Gaussian. So that occupied orbitals are localized on non-metal, on oxidizing agent, on oxygen, and the unoccupied orbitals will localize on the metal. So if you do the same format for titanium dioxide, you'll see that HOMO will sit on oxygens only. It is what you have by now. And if you add to this image another orbital, LUMO, you will likely observe that it will sit on the titanium. And you will recognize typical shapes of d orbitals. Right? Here you do not see it because lead has complete d shell, right? And its chemistry is associated with s orbital, so s and p, so it is, you do not have exotic shapes.
Somehow I ended up with 63 atoms.
As opposed to
Like, how many was I trying to do? Okay. As opposed to 16.
sorry.
Yeah. That would probably be too many for fast bow.
Why?
I don't know. Isn't that a lot?
9 cubes of 60. I mean, use their transition.
Give it a run.
I mean, worst case scenario, it just takes a day.
Yeah.
Or 2 or 3.
Or like a week. It won't take a week.
No, it won't. Just make sure you have enough vacuum.
Yeah. My laptop's not nice and-
Okay, what did I do?
What?
Spectrum looks fine. I think.
But
Yeah, I don't know
That-
what's going on.
that shouldn't happen.
I should look at.
Yeah,
Look
where's
at
the
my
contract for that guy? I'm right here. I just
file contains.
did to agree.
Oh gee, it's already 7:30.
Energy. I'm always say 1 now instead of 2.
I don't know.
All the orbitals have only 1 electron. None of them have 2.
Mm.
I didn't hear anything.
I'm so confused. All I did was change a high spin from not being there to equals 2. So confused.
Same.
So confused.
Yeah.
What?
My dog.
That's your dots.
Yeah, do you see?
Looks a little weird. So many dots.
I don't know, man. Screw with the dots.
That?
All my orbitals have 1 electron instead of 2.
Alright, so this one's up
So I went in and changed I spin equals to 2. I ran it. And I get this is my DOS, which looks weird. Does that look weird to you? Why is it like that?
Do not plot. Just look inside out car and make your observations.
Okay.
Yes, list of orbitals. Before you go to plotting those, just observe what is different.
Well, also in my energy pop file, I have all my orbitals have 1 electron.
It's a good observation, but you better look into out car.
Okay. I don't know if I've ever looked into it. Okay.
Yeah.
Were you able to plot?
Yeah.
Okay. So I don't know how much of steam you have. If you're not departing yet, I can quickly go over anions and cations. And I need to go over orbitals with London, right? First. Orbitals. There is a
Grenoble?
Yeah. Oh. Setting up that rundown.
If you are looking for aesthetic images, there is one more option for drawing, which is volume slice. you may need and you may like it if you are interested in scanning tunneling microscopy. If not, it's just aesthetic things where it shows projection of orbital on one plane instead of three-dimensional.
I see, just it's
Wait, what's,
one kind of postcode.
what's it called?
Just optimize June or whatever June. Next campaign stuff. National Basketball Association.
I guess I was assuming that it wasn't that. Oh.
And you should know quantum mechanics is never intuitive.
So you need just narrow range in DVC.
Wait, so we're telling the input that there's something for because that was in part of what you said, right? That's the instruction for like what to do.
What is Q-chain?
Why do my orbitals have one electron?
What's that?
Why do my orbitals have one electron?
I don't
What am I
know.
supposed to do?
So here is the Q-chain. You run fast once again, and this is specific.
Wait,
Right.
You need to tell how many
so
orbitals are
basically,
stored in the
I
wave.
didn't have, I
So
wasn't
you
put
read
that, so I was just changing stuff, but
read-
it wasn't actually changing that.
What,
Oh yeah, that's
so what
right.
happens in the wave part? Is that
I'm
something
real bad at it.
Oh,
That's not something that you do.
That
before you
sucks.
run fast.
I need to do something.
yeah. Something with caffeine probably helps too.
I'm just confused as to why you're telling the input how many bands there are, because wouldn't figure that out.
Figure out. Oh.
Yeah, she'd love that.
I'll show the new procedure. It's common sense already.
Oh crap. That's not gonna work, is it?
What did you do?
Tried to run JMOL without tunneling through Clown.
Oh.
What? No way. I'm not gonna get my hopes up.
Wait, did you copy the best? So I tried to do it, just didn't work. Like it just didn't recognize it.
Like,
I call it.
if it wouldn't have graphically tunneled, then it wouldn't have even opened up the
Mm.
JMOL logo. That's your cluster?
That is a lot of bonds.
Sorry.
Yeah. I'm just calculating the distance.
Is this the one you showed me earlier?
Yeah. I know. JMOL's always been slow for me though.
Yeah.
Okay.
So I don't just go.
Yeah. Well, it's 4 in all directions.
Exactly 4.
Yeah. So let's change that to like 6. 6 vacuum on each side.
I was told at least 7.
Okay.
Yeah, I was told 7. 10 is
Yeah.
so I'm not sure.
I'll just go with 7.
Sweet. Okay. Help me run through this real quick. Just make sure I understand here. So you are doing this rotation to make sure that coordinates all line up with the next one.
Yeah.
For your periodic intervals.
Mm-hmm.
And so you say 7, 7, 7 because you want 7 with angstroms or vacuum dimension.
Yep.
Okay, and then it outputs what here? And why does vector output?
I think this is just the dimensions of your box.
Oh, because 4 plus 7.
Yeah.
So that's your total marks.
Mhm.
Okay. So you only have to do that once, right? That's it.
Right.
Now you brand that.
Yeah. I don't know who that second person is.
It's not me.
This is gonna take a while, probably.
Probably.
It's running. You think anyone will care that it takes this long?
No.
Good.
Check your out card.
True.
No, not out card. Your out file. Your VASP dash clean dash number dot out.
Nothing yet.
Stop recordings.
It's running.
If needed, I will start again, but will it